Section 5.2, number 5, a research team conducted a study showing that approximately 15% of all businessmen who wear ties wear them so tightly that they actually reduce blood flow to the brain, diminishing cerebral functions. At a board meeting of 15 businessmen, all of whom wear ties, what are the following probabilities? Okay, so here's what we know. We are going to have, I'm going to write some of this stuff down so I have it in front of me. What I know is that, I'll write it way over here. N is equal to, what do we have? 15 businessmen. 15 businessmen. The probability of success, being a tie that's too tight, is also 0.15. Now we have a formula for binomial probabilities, right? Our formula is this one here. It is the probability that x is equal to r, x, the number of successes is equal to r, some number of successes, is, all right, n, choose r, times p to the r, number of successes, probability of success to the number of successes that you want, q, the probability of failure, to the number of failures that you want. Now, in part A, what we want is this. What's the probability of at least one is too tight? Now, these problems here, I like to write it in English first, and then I get a feel for what's going on. Well, how do I get at least one? Now, symbolize it. This means x could be greater than or equal to 1. But as soon as I see this at least, as soon as I see that at least business, I'm going to think opposite. Usually works out more quickly. So what's the opposite of at least 1? Now, as soon as I say think opposite, I got to think 1 minus. Now, the opposite of at least 1 is that x is none, all right, that you get 0. So let's find this number right here. We need to find that number. So we're going to do these strictly on the calculator. So on your calculator, type in, I'll do it over here on the left, type in this. 1 minus, all right? So start here, 1 minus. Now you have to go get the binomial distribution. So here's how you get it. You're going to press second, and then the VARS key. Now on the VARS key, when you press second, it really says distribution, right? So you press 1 minus, second VARS. Now scroll down to, let's see, we want number A, right? Scroll down to A. And A says binom PDF. Now we're using the P because there's precisely one value, right? One value, just x is 0. We use the C if there's more than one value. Now what you see is trials. All right, so put in the number of trials. Now we have 15, right? We have 15 businessmen, so put in 15. Probability of success on a single trial, so put in the 15. Now for probability of success on a single trial, for us that's 0.15. And the x value, well, we want 0 successes. Now go down to paste. So you press paste and press enter. And when you press enter, what comes up is, you can't really see it all, but it says binom PDF, and then it tells you 15.15, 0, and now press enter to actually make it compute. So when you press enter to compute, you get 0.91264 ... And it says round your answers to 3 decimal places. So 1, 2, 3, this is a 6. I'm going to round that up to 0.913. So I'm going to claim that that first one is 0.913. Now let's go to part B. So part B, what we want is the probability that there are more than 2. All right, now as soon as it says more than, you know, that's like this. It's this. The probability that x is more than. Now be careful. It's not this. That means more than or equal to 2. That means at least 2. We want more than 2, all right? So we have to be careful that we get the right sign here. More than 2. All right, now as soon as I see that greater than sign, I'm thinking think opposite. Because here's why. More than 2 could be what? this could be, X could be equal what? More than 2. You've got what? 15 businessmen. So X could be more than 2, could be 3 or 4 or 5 or 6 or ... all the way up to 15. Now you don't want to find each one of those individually. So what we're going to do is we're going to think opposite. So let's get rid of that. And we will say, think opposite. Because what is the opposite of, now as soon as you say opposite, 1 minus. Now what is the opposite of at most 2? Well, it could be, X could be what? 0 or 1 or 2, right? That's the opposite of more than 2. You could get something less, 2 or less, 0 or 1 or 2. Now this, we can do this directly on our calculator. So type in 1 minus. Now what you have to do is you have to go get that binom CDF this time. C, because we have more than 1. So here's what you're going to type. You're going to go to second, and then to vars, because the vars key, that's where distribution is. Right, so you get to second, vars, you got 1 minus, second vars. Now scroll to B this time. Let me just check that, be sure. Yeah, we want B, which is binom CDF. Now the last time we did it for PDF, we had a P for precisely one value. Now we have a C for accumulation of values, a cumulative score here. So you want CDF. When you have more than one value, you want the CDF. And then when you press B to select binom CDF, you get trials, type in 15, because we have 15 businessmen. P, probability of success on a single trial, that's still 0.15. The X value, now the X value is going to be this value right here. That's why I always write it down. It's going to be right there at the end. 2, 0, 1, or 2. This is an accumulator, so it's going to go from 0, 1 to 2. It always, the way the calculator is programmed, it starts at 0 and goes up to whatever number you have in there. So type in a 2, press paste, and when you press paste, what comes up is you can't see the whole thing, right? It's just, you kind of get MCDF, but it's really binom CDF, and you get 15.15, and then you get 2. Now press enter. All right, so you press enter to actually make it compute, and I come up with 0.39577, but we're supposed to round to 3 decimal places. So 1, 2, 3, I'm going to bring that up to a 6, 0.396. So I'm going to go up here to the top. In part B, I will say 0.396. And here in part C, we want the probability that no tie is too tight. Now, a tie being too tight, that's a success. So what we want is probability X is 0. Well, we can get this on the calculator directly. Let's just go to, all right, I'll just do it again here. Probably already know how to do it. Not stat, where do we go? We go to second, vars. That's where distribution is. And now we want PDF. We want P because I got precisely one value right there. So I'm going to go to A. All right, so scroll down to A. So you scroll to A, and A is binom PDF. So we're going to press enter, and then we get trials, 15. P, still 0.15. But our X value now is 0. You paste, press enter, and I got, what can I write it here, 0.08735 and so on. Round to 3 places, 1, 2, 3, that's a 3, so I'm just going to cut that off, so I'm going to 0.087. So up here at the top, I'll claim this is 0.087. Now in Part D, they've turned it around on us a little bit. They're asking at least 13 are not too tight. So before what we were doing, we were letting P, the probability of a success, that was 0.15, and that was when a tie was too tight. Well, now we've turned it around, and now what we want is for a tie not too tight. So what's this P going to be? Probability of a tie not being too tight must be 0.85. All right, that's what we're going to use for our P value. Now I see that we've got at least 13 not too tight. And here's that at least business again, right? At least. So I'm going to think opposite. So I will think opposite. And as soon as I think opposite, I'm thinking 1 minus. Now, what is the opposite of at least 13? Well, 13, at least 13 goes what? 13, 14, and 15, right? I'll do it right up here. Now, what's the opposite of this? Well, it goes from 12 all the way down to 0, right? So this is going to be, x could be what? 0 all the way up through 12. Not a problem. We can do that with binom CDF. So type in 1 minus binom CDF, right? C because we have a collection. C for collection. Binom CDF. And how do you get it? Second, VARS. That's where distribution is. Scroll down to B, and that's where you get binom CDF. Right, so binom CDF, that's the one you want. It will come up trials. We have 15 trials. P, now this is the new probability of success. Probability of success now is 0.85. And then, what do we have? The X value? Well, our X value is, that's why I like to write it out. My X value is right here, 12, because I'm thinking opposite. So I'm going to put a 12 in here, and then we'll paste, and then we'll compute. And when I computed that one, I got 0.6042, but I'm rounding off the 3 places. So let's just round it right off there, 604, and I will make that statement up here at the top, 0.604.